Good morning, student. So today this is our third lecture on gravitation, and in today's lecture we will simply derive the expression for acceleration due to gravity on the surface of Earth and how this acceleration due to gravity is varying with variation in height of the object from the surface of Earth or with the variation in the depth of the object below the surface of the Earth. What is the value of acceleration due to gravity at the center of the Earth? Means dependence of acceleration due to gravity on various parameters we will discuss one by one. So let us first discuss what is the expression for acceleration due to gravity G. See here, according to universal law of gravitation, if we are having a point object of mass small m, there is another point object of mass capital M such that the 2 point objects, they are separated by a distance r. Then the gravitational force of attraction, between them is F equal to Gmm divided by what? R square. Here a particle of mass m will attract another point particle of mass small m. Now, suppose we want to find out the force of gravity on a point particle of mass small m. We want to find out what is the gravitational force acting on a point object of mass small m due to an extended object like Earth. We can make use of same formula, and if I say here mass of Earth is m, mass of that point object is m, and if the distance of that point object from the center of the Earth is same as that of this distance r. Remember, because Earth is extended bodies, and while calculating what is the force of gravity acting on a point object of mass m due to this Earth, we must calculate the gravitational force of attraction between a point particle of mass small m and Earth of mass capital M. But remember, the distance of separation between Earth and that of point mass, it is measured from what? Center of the Earth to that point mass. Why it is so? That extended body, which is an Earth, whose shape we are taking it granted as a spherical, and for a sphere, the point at its center is that point where the whole mass of body is supposed to be concentrated. So whenever we have to find out the gravitational force exerted by the Earth on a point particle of mass small m, that gravitational force exerted by Earth on a point object of mass small m, then it must be given as Gmm upon r square. Means you measure the gravitational force of attraction between the point particle and the center of Earth of mass m, and the distance of separation between them is what? Distance of that point object from the center of the Earth, because when we had just derived the expression for that Newton's law of gravitation, we had also discussed the case that extended bodies, if that extended body is a sphere, then the whole mass of that sphere is supposed to be concentrated at its center. So the situation here is that the gravitational force experienced by a point particle of mass small m is F equal to Gmm divided by what? R square. If this point particle is not acted upon by any other force, means when no force rather than except this gravitational force exerted by Earth on that point particle, if no other force is acting on that point particle, the only force which is acting on particle is what? It is the gravitational force exerted by earth on that point particle. Then that point particle, it starts moving towards the earth. It gets attracted towards the earth. It moves towards the center of the earth with a force F equal to m into a, where a represents the acceleration with which that point particle is moving towards the center, and that acceleration, it is known as acceleration which is resulted due to gravity. Means here a represent acceleration due to gravity of the earth. A represent what? A equal to g. G means acceleration due to gravity. So according to Newton's second law of motion, F is equal to ma, but A equal to g means F is equal to what? M into g. But the force experienced by a point particle of mass m, it is given by g mm divided by r square, which is gravitational force. And according to Newton's second law of motion, the force acting on point particle, it is F is equal to mg. So these two equations, they will represent one and the same thing, that this particle, point particle of mass small m, is acted upon by a force either gmm upon r square or F is equal to mg. Means we can equate their right hand side. So gmm upon r square is equal to m into g. This small m on two sides get cancelled. So we will have an expression that acceleration due to gravity, which is acting on a point particle of mass small m, situated at a distance r from the center of the earth, is g equal to gm divided by r square. Now here we had considered that point particle is at a distance r from the center of the earth. In case if that point particle is lying on the surface of earth itself, means here what happens to this distance small r? It becomes equal to capital R, where capital R is radius of earth. So when object is on the surface of earth, when that object of mass small m is on the surface of earth, then what happens? Small r becomes equal to capital R, or g on earth's surface. G on what? Earth's surface. You can find the value of g on earth's surface just by putting the value of small r equal to what? Capital R. So g on earth's surface, it becomes equal to gm divided by r square. And from this expression, again we can draw the conclusion that acceleration due to gravity for all the objects near to the surface of earth, it depends only on the properties of earth, like mass of earth, density of earth, radius of earth, volume of earth. But acceleration due to gravity, which is acting on the object, it does not depend on mass of that object. Value of g, it does not depend on mass of the object. That is what Galileo has proved in his experiment, just by releasing the two objects, one heavier, other lighter, from the top of Pisa Tower, and he had proved that both the objects, even though their masses are such different, both of them, they will fall on the surface of earth with constant acceleration at the same time, and this proves that whatever Galileo has made this statement, it can be proved with the help of this mathematical equation, that is the value of acceleration due to gravity for all the objects near to the surface of earth, it is gm divided by r square. It depends only on the properties of earth and not on the mass of the object on which that acceleration due to gravity is acting. Acceleration due to gravity is acting. Now we will see how to find out acceleration due to gravity at a height h above the surface of earth. Now we will see how this acceleration due to gravity g, it is varying with a variation in the altitude of an object. Altitude is nothing but height of the object from the surface of the earth. Means we want to see what is the effect of height of the object from the surface of the earth. So let us consider here we are having an earth of mass capital M. So M represent mass of earth. M is what? Mass of earth. Capital R, it represent what? Radius of earth. And let us consider that we are having an object of mass small m. Object of mass small m. We know that acceleration due to gravity G. What is the general formula for acceleration due to gravity? G is equal to Gm divided by small r square, where small r represent the distance of that object from the center of the earth. It is in general expression for acceleration due to gravity. Here, if I just consider that an object of mass small m, it is lying on the surface of the earth. So, on the surface of the earth, when that object is on the surface of earth, then what is this radius of that, or what is the distance of that object from the center of the earth? When object itself is lying on the surface of the earth, then the distance of that object from the center of the earth is nothing but radius of the earth. So what we can say? Acceleration due to gravity on the surface of the earth. Acceleration due to gravity, that is acting on that object on the surface of the earth, is G equal to Gm divided by what? Here you can put small r is equal to capital R, because you are taking it granted that object is lying on the surface of the earth, means that distance small r becomes equal to capital R. So G equal to Gm divided by capital R square. This gives an expression for acceleration due to gravity for an object which is lying on the surface of the earth. Now let the same object is taken to a height h above the surface of earth, means the object of same mass small m, same object of mass small m, when it is taken to a height h above the surface of the earth, then what is the acceleration due to gravity acting on that object? Because in general G equal to Gm upon R square. When object is taken to a height h above the surface of the earth, means G, acceleration due to gravity at a height h above the surface of earth. Gh represent what? It is acceleration due to gravity at an altitude. Acceleration due to gravity at an altitude. Altitude means height. So acceleration due to gravity at a height h or at an altitude h, it can be just obtained just by replacing small r is replaced by r plus h, because what small r represent? It always represents the distance between that point object and the center of the earth. See here, when I lift the object to a height h, what is its distance from the center of the earth? It is r plus h. Means you replace small r by r plus h, use the general expression. So acceleration due to gravity at an altitude h or at a height h above the surface of earth, it is given by Gh is equal to Gm divided by R plus h whole square. Gh is equal to Gm divided by R plus h whole square. So we are having now the values of acceleration due to gravity which is acting on the same object. First, that object is kept on the surface of the earth and its value is what? Gm divided by R square. Then the same object is taken to a height h above the earth's surface. Then the acceleration due to gravity acting on that object, it is Gh is equal to Gm upon R plus h whole square, where Gh represent acceleration due to gravity at an altitude h or at a height h above the surface of the earth. Let us now divide equation 2 by equation 1. So what we will get? Gh upon G, Gh divided by G equal to Gm divided by what? R plus H whole square upon this G is what? Gm divided by R square. So this Gm get cancelled and we are left with R square upon R plus H whole square, or acceleration due to gravity at an altitude h is equal to G into R square divided by R plus H whole square. R plus H whole square. Now see here, as the height of that object above the surface of earth goes on increases, as the height of object above the surface of earth, it goes on increases. What happens to the denominator? R plus H whole square will also goes on increases. And when denominator increases, what happens to that ratio? It will decreases. So therefore GH will goes on decreases. So what conclusion we can draw here? That acceleration due to gravity at a height, acceleration due to gravity acting on an object will goes on decreasing as the height of object above the surface of earth goes on increasing. Means GH goes on decreasing. Acceleration due to gravity acting on an object at a height will goes on decreasing when the height h goes on increasing. See, it means they are what? Inversely proportional. Acceleration acting on an object will goes on decreases as that object is moved above and above the surface of earth. Means as the height goes on increases, acceleration due to gravity acting on that object goes on decreases. Is it clear? Now you can take R common. So the expression will be G into R square divided by, see here, when I take R common, what is left here? 1 plus H divided by R. 1 plus H divided by R and its square. That square is as it is. Or when this R is taken outside, means it becomes R square. So G into R square divided by R square in bracket 1 plus H by R whole square. 1 plus H by R whole square. Now here GH means acceleration due to gravity at a height h is equal to, see what is that expression? G into R square upon R square in bracket 1 plus H by R whole square. This R square get cancelled with R square. And remember that if the height of object is not that much greater as compared to that of radius, means when H is less than, very less than R, means object is lifted very close to the surface of earth as compared to radius, the height to which object is lifted is very small. Means when H is very less than R, naturally H by R is very less than 1. So this GH, which is equal to G into, see here, G upon 1 plus H by R whole square. You know that 1 upon A raised to X is equal to A raised to minus X from the laws of indices. So this becomes what? G into, can I write 1 plus H by R raised to power minus 2? Remember, by using binomial expansion, because H by R is very less than R, means higher powers of H by R is very small and that can be neglected. So the expansion of this is G into, if you expand it, it is 1 minus H by 1 minus what? 2H divided by what? R plus H square by R square and so on. But that terms of H square by R square, because H by R itself is very small, so the terms containing higher powers of H by R can be neglected. So we are left with G in bracket 1 minus 2H divided by R. 1 plus h by r raised to power minus 2, it becomes 1 minus 2h by r by approximation. So acceleration due to gravity at a height h is equal to g in bracket 1 minus 2h divided by r, and by using this expression, you can find what is the acceleration acting on an object which is at a height h above the surface of the earth. Now we will see how this g will vary with variation in the depth. So let us study how this acceleration due to gravity g is varying with variation in the depth at which that object is lying below the surface of earth. Now all of we know that as far as our planet earth is concerned, how is the shape of earth? Earth is considered to be spherical in shape. If I say m is the mass of earth and r is the radius of earth, mass and r represent the radius of earth. Here earth is shown by means of that outer sphere, outer circle, outer sphere. Mass of earth is capital M, r is radius of earth. Earth is spherical in shape. Remember, as far as this derivation for variation in g with depth is concerned, it is totally based on the assumption that the spherical earth is made up of large number of concentric uniform spherical shell. Large here, each circle will represent a shell. Shell means hollow sphere. All the spherical shells, they are having a common point, means they are concentric. Their density throughout the shell is uniform. So what I am saying, that earth of mass m, which is spherical in shape, is supposed to be made up of large number of concentric uniform spherical shell. Large number of what? Concentric uniform spherical shell. So due to this, when I say that object of mass small m, suppose we are having some object of mass small m as compared to that of mass of earth, mass of object is negligible. So naturally that object is attracted towards the center of the earth due to what? The gravitational force exerted by earth on that object. And remember that when object is lying on the surface of the earth, we must assume that the entire mass of earth is supposed to be concentrated at its center, so that the distance of separation between that object of mass small m and the center of the earth is nothing but radius of the earth, and therefore the acceleration due to gravity acting on the object lying on the surface of earth, we know that this g is equal to gm divided by what? R square. This is equation number 1. What this small g represent? It is the acceleration due to gravity acting on an object lying on the surface of the earth. G equal to gm divided by r square, where m is the mass of earth. Capital M represent what? Mass of earth. And this is also radius of earth. Because we know that density is equal to mass upon volume. Density is equal to what? Mass upon volume. Rho is equal to m divided by v. Rho is the density of earth. Capital M, it is the mass of the earth, and v is volume of the earth. Therefore, mass of earth is equal to rho into v, equal to rho into. Now, how to calculate the volume of earth? See here, earth is spherical in shape. What is the volume of sphere? It is 4 by 3 pi r cube. Radius of sphere is capital R. So the mass of earth, it can be expressed in terms of density of earth and that of what? Radius of the earth. So you can modify the expression for acceleration due to gravity acting on the object lying on the surface as g equal to capital G, that is universal gravitational constant. This mass of earth, you can replace it by this factor, but in the denominator, that r square, you write it as it is, into, here this mass will be replaced by rho into 4 by 3 pi r cube. R square, r cube, only r is left here. So G, that is acceleration due to gravity, acting on the object lying on the surface, it becomes 4 by 3 pi g rho into r. 4 by 3 pi g rho into r. So this is equation number 1 or equation number 2. Equation number 2. So here we are having an expression for acceleration due to gravity in terms of density of earth, in terms of radius of earth. Let us consider the situation that an object of mass m now it is brought at point P, which is at a depth d below the surface of earth. From the surface of earth at a depth d, there is a point P where that object of mass small m is kept. When object is kept at a depth d below the surface, over that object, the force exerted by material which is lying outside the inner sphere is 0, because it is spherical in shape, and already we had studied that whenever a point particle is kept anywhere inside the spherical shell, the gravitational force or the acceleration due to gravity on it is equal to 0. So in a single line, that is most important line, that on the object of mass small m which is kept at a depth d below the surface, the material which is lying outside the inner sphere, here I had shown that material outside the inner sphere by means of what? Shaded portion. That the force exerted by material outside the inner sphere is 0 due to symmetry, means that object is simply acted upon by the gravitational force exerted by the material of inner sphere. And if I say m dash is the material of inner sphere, r minus d, see here, this total distance is what? R, radius of earth. This is depth d, total distance r, this is depth d, it means what is the radius of inner sphere? It is r minus of d. So when particle is at a point P, the gravitational force acting on that particle is only due to the material of inner sphere, and hence what is that mass of inner sphere? M dash. What is that radius of inner sphere? R minus d. So as per this equation, acceleration due to gravity acting on object of mass small m which is kept at a depth d below the surface is g suffix d is equal to g into what is the mass of inner sphere? M dash, upon what is the radius of inner sphere? R minus d whole square. See here by analogy. Now as far as that m dash is concerned, what is that m dash? It is mass of inner sphere. Mass of inner sphere m dash is equal to, see here, mass is equal to density into volume. So density into volume of inner sphere, say it is V dash, smaller as compared to that of what? The outer one. So m dash is equal to rho into, how to calculate the volume of inner sphere of radius r minus d? It is 4 by 3 pi into r minus d whole cube, because radius of inner sphere is r minus d. Just like in this case, here you can also express acceleration due to gravity at a depth d in terms of density of earth. So GD is equal to G by r minus d whole square into, now m dash you can replace it by rho into 4 by 3 pi into r minus d whole cube. R minus d whole square, r minus d whole cube. So that square get cancelled, leaving only r minus d. Therefore, GD is equal to 4 by 3 pi rho g into r minus d. So this is an expression for acceleration due to gravity acting on the object lying at a depth d below the surface of earth as GD equal to 4 by 3 pi rho g r minus d. Now you can take the ratio of these two, because every now and then you have to calculate the relative acceleration due to gravity for an object lying below certain depth from the surface of the earth. So if I take the ratio of equation 3 and that of equation 2, so what I will get? That GD upon G is equal to 4 by 3 pi rho g into r minus d upon 4 by 3 pi rho g into r. 4 by 3 pi rho g into r. Cross verify 4 by 3 pi rho g into r. Similarly 4 by 3 pi rho g into r. So here 4 by 3 pi rho and g, they get cancelled. Therefore GD upon g is equal to r minus d upon r. You can split it, r by r minus d by r, or it is equal to 1 minus d by r. So GD is equal to 1 minus d by r into g. So GD is equal to what? G into 1 minus d divided by r. So see here that if the depth of object goes on increases, means when the depth of object goes on increases, means when that object is moved inner and inner, that is near to what? The center. With the increase in depth, this is d by r. When d increases, d by r increases, means 1 minus d by r decreases, means GD will decreases. So you can make a general statement that acceleration due to gravity at a depth goes on decreases when depth goes on increases, and when that object is kept at a depth d equal to radius of the earth. Ultimately it means where is that object situated? When object is situated at a depth d equal to r, means that object is lying exactly at the center of the earth. So when d is equal to r, from this expression GD is equal to G into 1 minus r by r. R by r is 1. So 1 minus 1 is what? 0. So GD is equal to 0. So you must remember this important characteristics, that acceleration due to gravity at the center of the earth is always 0. Means when you keep the object at the center of the earth, what is the acceleration due to gravity acting on that object? It is 0. Now we will see how this acceleration due to gravity will vary when we move the object either to a height above the surface of earth, or to a height or to a depth below the surface of the earth. So variation in the value of g with variation in height or altitude, or variation in what? The depth of an object. Depth of an object. Let us see the graphical representation of variation in acceleration due to gravity with depth and with altitude, or on the surface of earth. Just now we had derived that when an object is taken, an object of mass small m, when it is taken to a depth d below the surface of earth, this is earth surface, and below the surface of earth, when object is taken to a depth d below the earth surface, then the acceleration due to gravity acting on the object at a depth d, it is GD equal to G into 1 minus d divided by r. If that object is taken to a depth d equal to r, then what is this? GD is equal to see here, GD equal to G into 1 minus R by R. What is R by R? 1. 1 minus 1 is 0. Means any object of any mass, whenever it is kept at the center of the earth, acceleration due to gravity or the gravitational force acting on any object at the center of the earth is equal to what? 0. It is equal to 0. Similarly, if that object is lying on the surface of the earth, object is lying on the surface of the earth, then what is the acceleration due to gravity on the earth's surface? On the earth's surface, acceleration due to gravity is G into m divided by what? R square. See here, all the terms, universal gravitational constant, mass of earth, radius of earth, they are all constant. And the value of that constant, it comes to be 9.8 meter per second square. And remember that when object is on the surface of earth, means the distance between that object and the center of earth is small r. Always remember, small r represent the distance of separation between what? The two particles, between which we are measuring the gravitational force. So when object is lying on the surface of earth, r is equal to what? Radius of earth. And acceleration due to gravity on the surface of earth is maximum, and that maximum value is 9.8 meter per second square equal to G. Now we want to see, we know very well that when object is moved to a depth below the surface, or object is moved above height, or object is moved to a height above the surface of earth. Remember that acceleration due to gravity, when object is taken to a depth, will decreases when the depth of object goes on increases, or the value of acceleration due to gravity acting on the object at a certain height, again it will decreases when the height of object increases. Means in both the situation, see what happens? GD is equal to G into 1 minus D by R, and GH is equal to G into R square divided by R plus H whole square. What I am saying? That acceleration due to gravity G will decreases when the depth at which that object is kept will increases. See here, as D increases, D by R increases, 1 minus D by R decreases, means GD decreases. So GD decreases when depth increases. Or acceleration due to gravity on the object at a certain height will decreases when the height of object from the surface of earth increases. See here, when H increases, denominator increases, means that fraction will decreases. So acceleration due to gravity decreases in both the cases, whether the depth of object goes on increases, whether the height of object from the surface of earth goes on increases. We want to have the graphical variation of G with R. Here what this R represent? If I say that here small r is equal to R minus D, or here small r is equal to R plus H, actually it is. If I say that object is at this point, that is at a depth D, then what is the distance of that object from the center of the earth? It is small r equal to R minus D. Or when I say object is at a height H above the earth's surface, then what is the distance of that object from the center of the earth? Small r is equal to R plus H. So for the depth, for the object lying at certain depth, small r equal to R minus D. For the object lying at certain height, R is equal to R plus H. So here G becomes the function of R. So G depth, which is a function of r, is equal to, see here, g into 1 minus d by r. So it can be written as what? R minus d upon r. But r minus d is replaced by r. So it is g into r divided by what? R. Or gh becomes equal to g into r square divided by this r plus h is replaced by what? R square. And this is also becomes a function of r. So acceleration due to gravity, which becomes a function of r, when we are considering what? Body is moving to a depth, it is varying linearly with r, and here acceleration due to gravity, which becomes function of r, it varies inversely with the square. So see how g is varying when object is moving inside the earth, and how g is moving when object is moving above the surface of earth. When object is moving inside the earth means in a depth, g varies linearly with r, means how is the relationship between them? It must be a straight line. See here, object is on the surface of earth. As we move near and near to the center of earth, means depth will goes on increases. When depth goes on increases, r goes on decreases. When r goes on decreases, g will also goes on decreases, and when object it reaches the center, g becomes equal to what? 0. When object reaches the center means d is equal to r minus r is 0. So here is the situation when that object is at the center of the earth, and here value of g is 0. Object is on the surface of the earth and value of g is maximum 9.8. And from this point to this point, as we move in this manner, means depth will goes on increases. So value of g goes on decreases, and that variation is a linear variation, which is a straight line passing through origin. Similarly, as far as acceleration due to gravity with variation in altitude or variation in height is concerned, it varies inversely with the square of r, means it obeys inverse square law. So that relationship, here r is less than r, here small r is greater than r. Above height means smaller is greater than radius of earth. Below the surface means smaller is less than r. So for r greater than r means body is moving to a height above the surface. G is inversely proportional to r square. So we will have exponential decay curve. So this is how g is varying either with respect to what? The depth, or with respect to altitude or a height, h. Now we will see the next variation. Now let us see how the acceleration due to gravity g is varying with variation in latitude of the particle as well as due to the rotation of the earth, how the acceleration due to gravity will get affected. So here I have shown our planet Earth. So let us first see what is the meaning of latitude of a particle. Suppose we are having some particle of mass m. Let it be kept at point P. Let O is the center of Earth. Then OP represent the radius vector, or it may be a position vector of a given particle. And here OE represent what? OE is a line segment in the equatorial plane of an earth. So as far as the latitude of any particle is concerned, latitude of particle on the surface of earth is nothing but angle made by radius vector or position vector with the equatorial plane of the earth. Angle between OP and that of OE is nothing but latitude. Angle made by radius vector or position vector of a particle with the equator of the earth is called latitude of a particle. So as far as a particle of mass m is concerned, it is kept at point P, and the position vector OP makes an angle theta with the equator. So angle POE, angle POE is called the latitude of angle POE is equal to theta, and that theta is called as latitude of particle P. See here, if particle itself is lying on the equatorial plane of Earth at any point on the equator of Earth, what is the angle made by radius vector with the equatorial plane? Theta is 0. Means the minimum value of latitude of a particle is 0. And as particle is lying on the surface which is moving towards what? Polar axis, angle theta goes on increases, and finally when given particle lies on North Pole or South Pole, what is the angle made by radius vector with the equator? It is 90. So as far as latitude of any particle on the surface of Earth is concerned, it changes within the range of theta equal to 0 on equator to a maximum value of theta equal to 90 degree on what? On the pole. So is it clear? What is latitude? Angle made by radius vector or position vector with the equatorial plane of an Earth. Now see here, this is the polar axis, vertical line. It represents what? Polar axis of Earth. Earth rotates about its polar axis. Earth will rotate. See here, this is east, this is west. And here I have shown that Earth is rotating in this manner. Means Earth rotates about its polar axis from west to east with a uniform angular speed omega. Earth is rotating with a uniform angular speed omega in a direction from west to east. And due to this rotation of Earth about its polar axis with a constant or uniform angular speed, every particle on the surface of Earth, see a particle at point B, every particle on the surface of Earth will perform a circular motion, or it will travel along a circle which is parallel to the equator of Earth. So a particle of mass m at position P, it travels along a circular path of radius r which is parallel to the equatorial plane of Earth, which is parallel to what? Equatorial plane of Earth. So the circular path traced by particle of mass m at point P. What is the radius of that circular path? Radius of that circular path is small r, means PO dash. PO dash is equal to r, where O dash represent the center of that circle. Center of that circle. Now, as far as particle P is concerned, what is the latitude of particle at position P? It is theta. Now see here, this circle is parallel to the equatorial plane of Earth. It means the radius vector of this circle is parallel to the radius vector of what? Equatorial plane. Means this side and this side, they are parallel. Small r and capital R, that is radius of Earth, they are parallel, and this will represent that position vector will be the transversal of parallel lines, and if this angle is theta, then the corresponding angle OPO dash, angle OPO dash is also equal to theta, which is nothing but latitude of particle at point P. Latitude of particle at point P. Now let us consider the right angle triangle OO dash P, yeah, OPO dash. So in triangle OO dash P, this is the right angle triangle. What is cos of theta? cos of theta is equal to adjacent side. See here, this angle is theta. So what is the adjacent side? This is PO dash. And what is hypotenuse? PO. So PO dash divided by PO. But what is PO dash? PO dash is nothing but radius of circle traced by particle at point P. So this is small r divided by PO. It represents the radius of Earth, that is capital R. So therefore, that small r is equal to capital R into cos of theta. Small r is equal to what? Capital R into cos of theta. Particle at point P is performing circular motion. When object performs circular motion, means for circular motion that object must be acted upon by what? Centripetal acceleration. Means on an object of mass m, in order to perform circular motion that object must be acted upon by what? Centripetal force, CPF, and that centripetal force is mr square into omega. mr omega square, or it is equal to mv square divided by r. mv square divided by r. So centripetal acceleration acting on a particle of mass m, because particle of mass m is performing circular motion, it means it is acted upon by centripetal acceleration. A is equal to that centripetal acceleration A, it acts along the line PO dash, that is along the radius and directed toward the center O dash. So centripetal acceleration is r omega square. What is this A? It will give us the centripetal acceleration acting on particle at point P. But we know small r is equal to r cos theta. So centripetal acceleration A is equal to r omega square into cos of theta. R omega square into what? Cos of theta. Now see here, this centripetal acceleration, it is a vector. Centripetal acceleration is what? It is a vector. And we can resolve that vector into two components. And if I just consider, see here, centripetal acceleration, vector A. And when this vector A is resolved into two components, then that component which makes an angle theta with the given vector, it is A cos of theta. So here, the component of centripetal acceleration along OP, see here, component of A bar along what? Along OP or along PO is AR bar. You can resolve this vector A into one of the component AR which makes an angle theta. So we know that AR is equal to A cos of theta. AR is equal to what? A cos of theta. So by using equation 3, equation 4 becomes, you can put the value of A here in this expression. Therefore, AR is equal to, now in place of A, I can write R omega square cos theta into cos of theta. Or it is equal to R omega square cos square theta. AR is equal to R omega square cos square theta. R omega square cos square theta. This is equation number 5. So AR represents the component of centripetal acceleration A acting on particle at point P towards point what? O dash, and its component along what? Component along PO. It is r omega square cos square theta. So this component of centripetal acceleration, which is acting on the particle at point P, which is directed toward the center O of the earth, it helps to reduce the gravitational force acting on particle at point P. So the net effective gravitational force, acting on a particle of mass m at point P, which is at a latitude theta, it is given by mg dash is equal to mg minus of mr omega square cos square theta. So the net gravitational force at any point on the surface of earth which is at a latitude theta and which is due to rotation, that net gravitational force is reduced by this much amount, that is m into r omega square cos square theta. So I can cancel m on both the sides. So we will have g dash is equal to g minus r omega square into cos square theta. This will give us the net acceleration due to gravity at any point P on the surface of earth at a latitude theta, and that is equal to g minus r omega square cos square theta. Remember that as far as this latitude theta is concerned, when theta goes on increases, see here, you know that how cosine of an angle is varying with respect to time. Angle is 0, here angle is what? Pi, and pi by 2, and here angle is pi. So when theta is 0, cos theta is 1, and as we move from 0 to 90, see here, cosine of theta goes on decreases. When cos 90 becomes cos theta, it becomes cos pi by 2. Then cos pi by 2 is equal to what? 0. So from this expression, when this latitude of particle theta goes on increases, what happens to the cos theta? As theta increases, cos theta goes on decreases, because latitude can have a minimum value 0, maximum value what? 90. Means when angle is changing from 0 to 90, cos will decreases from 1 to 0. So when angle theta increases, cos theta decreases, means this term will decreases, means g dash will goes on increases. So in order to increase the theta, we must move from what? At equator, theta is 0. As a particle moves from equator towards the pole, theta goes on increases, and when particle reaches to pole, theta becomes 90 and cos 90 becomes equal to 0, and this g dash becomes equal to what? G. G dash becomes equal to G. So this is how, so that's why we are always saying that acceleration due to gravity, at the pole, it should be maximum and it should be minimum at the equator. So there are two special cases that we will consider. The first case, it is for equator, at equator. At equator. What is angle theta is equal to? 0. When particle is at equator, theta equal to 0. Theta equal to 0 means cos 0 equal to plus 1. Cos 0 is plus 1, means cos square theta is equal to 1 square is equal to 1. Therefore, g dash minus of, or g dash is equal to g minus r omega square, or g minus g dash is equal to r omega square. G minus g dash, that is change in or variation in G with latitude. G minus G dash is equal to R omega square. We know radius of Earth 6.4 into 10 to the power 6. We know that omega is equal to 2 pi by t, that is equal to 2 into 3.14 divided by, what is the time period of Earth? 24 hours into 60 into 60 into 60. And if you just calculate G dash minus G, which is equal to R omega square, you can put the value of R and omega square by using this value, then this difference comes to be 0.033 meter per second square, roughly meter per second square. Or G dash is equal to G plus 0.033, or G is equal to G dash minus 0.033. So at the equator, value of acceleration due to gravity is always equal to 9.7804 meter per second square. So this is about equator. On the pole, when particle is on the pole, what is angle theta is equal to? When particle is on pole, means here angle theta is equal to 90 degree. Cos 90 is 0. Cos of 90 is equal to 0. Therefore, G dash is equal to G minus R omega square into 0, or G dash is equal to G, equal to 9.8372 meter per second square. So from this value 9.7804 and 9.8372, we can make a conclusion that acceleration due to gravity at any point along the equator of Earth, at any point along the equator of Earth is less, that is 9.7804, while acceleration due to gravity at any point on the pole, it is maximum, that is 9.8372. Remember here that as far as shape of Earth is concerned, shape of Earth, all of we are considering that Earth is spherical in shape. Actually, Earth is not spherical in shape, but it is ellipsoid. It is what? Ellipsoid. It is bulged at the equator. It means the radius of Earth along the equator is equal to 6378 kilometer, while the radius of Earth along the pole is equal to 6356 kilometer. Means the radius of Earth along the equator is greater, while radius of Earth at the pole is what? Somewhat lesser. And second thing that you have to remember, that the particle at the pole, they are not performing circular motion, means particle at the pole, because they are lying along the axis of rotation, they are not revolving, means there is no effect of rotation of Earth on the particle at the poles. And second thing, radius at the pole is less, so that's why acceleration due to gravity at the pole is more, whereas particle at the equator, there is an effect of what? Effect of rotational motion of Earth, as well as what? Radius of Earth along the equator is more, so that's why acceleration due to gravity at the equator is what? Less. So this is all about how the acceleration due to gravity G is varying with latitude, and what is the effect of rotation of Earth on acceleration due to gravity.